of amines. According to Bronsted-Lowry theory, a base is a proton acceptor. It can accept H+. An amine is a nucleophile, or we call it a Lewis base. Amine is a base because of its lone pair on nitrogen atom. Nitrogen atom in amine has one lone pair. The strength of base depends on the ability of lone pair electron on the nitrogen to be donated to H+, or to be simplified, you can understand the ability of lone pair electron on N to accept H+. That's what we can see about the strength of base and the stability of conjugate acid or alkyl ammonium ion form. Base strength is influenced by the inductive effect and resonance effect. First, we are going to look at the inductive effect. An alkyl group, we know that alkyl group is electron donating group. We learned in the previous chapter, alkyl group is electron donating group. It donates electron. It will increase the electron density on the nitrogen atom because we know nitrogen atom has a lone pair of electron. If it attached to alkyl group, the alkyl group will donate the electron, means the alkyl group can increase the electron density on the N atom. Basicity of amines increases with the increasing of alkyl group, means if the electron density is higher in nitrogen atom, it is easier to accept the H+. When it is easier to accept H+, it will become more basic. Because we know base, it will accept H+. If the N has higher electron density and has higher ability to accept H+. So when it has the ability to accept H+, the basicity of amine increases with increasing alkyl group. When the number of R increases, electron density on nitrogen atom increases, lone pair electron can be easily donated, or lone pair electron can be easily accept H+. So the basicity increases. The R group stabilizes the alkyl ammonium ion by dispersing its positive charge. So here, the CH3, the electron donating group, it can increase the electron density because it is electron donating group, so it donates electron, makes this N has higher electron density. When this N has higher electron density, it can accept the H+, easily to accept H+, or in another word is this electron can be easily donated to the H+. And then the R group, here the R group stabilizes the alkyl ammonium ion by dispersing its positive charge. So it disperses the positive charge. Therefore, amines are more basic than ammonia. Amine has R group, ammonia has no R group at all. Ammonia NH3. Amine N has 1 R group or 2 R group or 3 R groups. Those are amines. If it has R groups, mean it is more basic because R group is electron donating group. The base strength is different in gas phase and in aqueous solution. In gas phase, the tertiary amine is more basic than secondary amine, more basic than primary amine, more basic than ammonia. So we can understand this because tertiary amine has more R group. When it has more R group, this 3 electron donating group, 3 alkyl group can increase the electron density at N. So when the electron density N increase, it can be easier to accept the H+. Okay, it can be easier to accept the H+. Secondary amine, 2 R groups only. 2 R group only to make this N electron density higher. In primary, 1 R group only that can make the electron density at N higher. but ammonia no R group at all. So in gas phase, we can understand why tertiary more basic than secondary, more basic than primary, more basic than ammonia itself. But in aqueous solution, it's a bit different. In aqueous solution, secondary amine is more basic than primary amine. We can understand this. But why tertiary amine is less basic than primary and secondary? Tertiary has more R group. Tertiary has more R group. So we can understand if it has more R group, more basic. But why here in aqueous solution, more R group but less basic than primary and secondary? The reason is the basicity of amines and aqueous solution depends not only upon the electron donating group but also upon the steric effect. In tertiary amine, it has highest alkyl group. 3 alkyl group means the steric effect, there is steric effect in the tertiary amine because more number of R group. Steric effect refers to the crowding alkyl groups. Here crowded. Primary amine, 1 alkyl group only, 1 hydrogen atom, small atom, not crowded. Secondary amine, 1 hydrogen, small atom, less crowded, but here less crowded than secondary. Primary less crowded than secondary, but most crowded in tertiary. Tertiary has 3 alkyl group, no hydrogen at all, no small atom at all, very crowded here. So steric effect refers to the crowding of alkyl groups around nitrogen atom, which hinders the attack of proton on the amine molecules, and this decreases its basicity. So here, if you look at tertiary amine, the H plus is hindered by, if the H plus want to be attacked by this electron, lone pair electron, it is hindered by CH3, hydrogen, 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 hydrogen. It is hindered by this big alkyl group. This one easier to attack H plus outside H plus because this 2 hydrogen atom is small atom only, but this CH3, 2 CH3 are very big, so it hinders the attack. So that's why the tertiary amine here is less basic than primary amine and secondary amine. Next factor is resonance effect. Resonance effect is the delocalization of electron in the ring. So, if you compare aniline, the benzene ring, with NH2 and the cyclic, not the benzene ring, this is this cyclic alkyl amine. In the benzene ring, the electron pair on the N delocalized, means this N, lone pair at the end, can move around the benzene ring. This electron can move around the benzene ring. That's what it means by delocalized. Electron, when this electron can move around this ring, the electron density on the N decreases. So that's what it makes the aniline or the amine with aromatic ring less basic compared to amine that has no aromatic ring. Amine that has no aromatic ring is more basic because the position of the electron pair on the N is localized. Localized means it's here, it's not moving anywhere, it's on the N. Aromatic amines are weaker bases than the corresponding aliphatic and cyclic amine because the electron on the N can move around the benzene ring. That's what makes the electron density on the N decreases and less basic because electron density less on N, so harder to attack the H plus, harder to receive the H plus. This is the resonance structure of delocalization of electron that stabilizes aniline. This electron lone pair can move to becomes a double bond C double bond N, and the C double bond C here becomes lone pair on this one carbon only, like this, one carbon only, and then two double bond here, double bond at N. That what makes the N plus. This carbon has lone pair, and this lone pair can be transferred to become the double bond here, and then when this here becomes a double bond, the double bond here becomes a lone pair on this carbon, and it moves around the benzene ring. Decreases the electron density on N, making aniline less basic than alkyl amine, because alkyl amine, the lone pair cannot move around the cyclic ring. Or here, if cyclo, electron cannot move around here because there's no double bond, there's no benzene ring. So when the N becomes plus, it is harder to attack the H plus. It needs higher electron density N here. So that's why the NH to the amine that has attached to the aromatic ring is less basic than amine which has no aromatic ring at all. So this is what we call by resonance effect. Base strength depends on the resonance effect. If we have an example of three compounds, para-nitroaniline, aniline, para-methyl-aniline, increasing basicity, the least basic is para-nitroaniline followed by aniline and para-methyl-aniline. Para-methyl-aniline is the strongest base because it has CH3 attached to the benzene ring. The CH3, we know that CH3 is alkyl group. Alkyl group donates electron. This is electron donating group. CH3 is electron donating group. When it donates electron, it can increase the electron density on the N. The lone pair on the N atom is easily to be donated, means lone pair can easily attack the H+. Aniline is less basic than para-methyl-aniline here. Aniline less basic because it is stabilized by resonance, no electron donating group, and then it has benzene ring. The benzene ring, the electron lone pair of the N, this N has electron lone pair. The electron lone pair delocalize around the ring. The delocalization of electron pair makes the electron density on N atom decreases. So less electron density here because the electron lone pair here can move around the ring. When the electron can move around the ring, low electron density, harder to attack the H+, harder to donate the lone pair electron. Finally, the para-nitroaniline. Para-nitroaniline, we have nitro group here, NO2 group. We know that NO2 group is the electron withdrawing group. It will withdraw the electron towards itself. Means the lone pair electron at the end will be withdrawn to the benzene ring, to the NO2. It will make this N has less electron density. So para-nitroaniline is the weakest base because it contains NO2 group, which is an electron withdrawing group. It decreases the electron density on N group because this NO2 withdraw the electron. It withdraws the electron towards itself. Thus, the lone pair electron on N atom is not available to be donated. That's why this is the least basic. Next example. Para-nitroaniline, aniline, cyclohexaamine. So, as I've mentioned before, this is the least basic because it has electron withdrawing group. And here, aniline, no electron withdrawing group, but it has benzene ring. So the lone pair electron delocalize around the ring, making this N has low electron density. This cyclohexanamine has cyclohexyl group here, cyclic ring, cyclohexyl group. This is R group. The R group is electron donating group. So this R group can donate electron to the N. When it can donate electron to N, that what makes N has higher electron density. It increases the electron density at N. localized on N. Localized means the lone pair is assigned there and it's not going anywhere. That's what it means by localized. So it increases the electron density on the N, therefore the lone pair is easily to be donated. It can easily attack the H+. So this cyclohexanamine is the most basic because it has R group. The electron donating group can donate electron to the N.